Hello and welcome to Interactive Stargazing tonight. My name is Ariel Daniel and I will be your host. Today we are using our 14-inch planewave telescope as well as our Malincam software. And starting off, we are looking at the moon. Now through the presentation, feel free to put in any requests into the chat and we'll do our best to try to grab those objects. I believe right now in Flagstaff, the moon is pretty bright tonight, as well as we've got some high clouds going on, but they should be passing through and we should be able to grab some stuff as the night progresses. So the moon is about 240,000 miles away. We can see these darker portions on the moon are called maria, and that is evidence of ancient volcanic eruption. We can also see all of these craters on the surface of the moon. Because of the moon's lack of atmosphere, these space rocks that come in and fly towards Earth, they burn up in our atmosphere, but the space rocks that come in and fly towards the moon, they don't really, they have nothing to burn up in, so we end up getting all these sort of like scars on its surface. Way back when the solar system was first forming, the moon was actually covered in these effusive volcanic eruptions, so really slow, mellow magma flows. And the moon's getting bombarded with all of these random space rocks. This calm magma filled in all of these craters, and that's why we see all of these darker sort of smudges on the moon. And I believe we can sort of zoom in and see more detail on that moon as well, Vic. I believe we can. We can see detail in the maria as well as in the craters. We can just kind of zoom around and see some of that. Nice. With a bright object and a close big object like the moon, sometimes we'll get this effect where it'll kind of look like the moon's wobbling or underwater. That's just atmospheric turbulence, just wind in our upper atmosphere, or wind passing over it, or some clouds passing over it. Now, let us see. I believe we have some requests already. Are we able to see Cassiopeia, a supernova remnant? Is that in the sky at all? The supernova is a little too faint to see. Also with the moon being too bright and the clouds passing overhead, we won't be able to grab that tonight. The Mercury is also not visible right now. So what we could try is the Crab Nebula, M1, from Lowell. We can definitely try it again with the moon out. It is a fainter object, but we might be able to see some of that supernova remnant. So the Crab Nebula, yes, the Crab Nebula is a supernova remnant, so the death of an incredibly, oh yeah, he's just barely in there. We could maybe up the exposure a little and then zoom in. We might be able to get a little more detail. So M1 is the first of the Messier objects. It is a supernova remnant, meaning it's the death of a very massive star, the death of a giant star. Giant stars, or like stellar deaths, or kind of like these stars in general are like these little element factories, and the heavier the star, the more massive the death. So lighter or average stars, they'll create lighter or average elements, the stuff that we see on the periodic table. And then heavier stars will create heavier metals. So like if you're wearing a gold ring, that gold is formed from within a supernova, like the Crab Nebula. Let's see. So M81 and M82 are a little too low, so we can't grab those guys. Let us see. M84 is a little too low as well. What is, let's see, M110, is that possible to grab it all? Also, I'm seeing a lot of requests for Messier objects, or M objects. There's, Messier 1 through Messier 110. And on March 13th, we will be having a Messier marathon. So we'll be trying to grab as many Messier objects as possible during a 12-hour live stream here on this channel. So if you happen to be up for 12 hours or want to tune in at like 4 in the morning, feel free. Okay, let us see. Chaitarai by Helianthus. Chaitarai is a star. That'd be fun. And we'll definitely be able to grab a neat little star. So you can see on the screen here that that map was kind of moving. I'm at my house, but we've got some people over at the Lowell Observatory right now operating the telescope. Ooh, a nice bright star. Neat. You can see that we're taking about a 7-second long exposure. You can see that exposure time at the bottom of the screen. Looks like it might be a binary star as well. So yeah, that's nice. I like that effect. You know, when we look at really bright stars, we see this sort of like a cross coming out of that star. And that is actually the light coming off of the secondary mirror in the telescope. The telescope that we're using is a reflector. So we have a large primary mirror and a smaller secondary mirror that's like kind of held at the top of the telescope. And that those streams coming out of the stars are from the secondary mirror being held inside of the telescope. Okay. Let's see. NGC 2354, Thor's helmet. So we can definitely try it out. It may be a little faint. I'm not sure. 23. What is it? Sorry. 2359. Okay. A nebula. So we might be able to see. Little too faint to grab him. Sorry about that. We'll blame it on the clouds. Request from Jose. Hi, Jose. NGC 2419. Are we able to grab that at all, or is it still a little too dim? 2419. So, Jose and I were hanging out one day, and I stumbled upon this object. Now, are we taking, oof, hello, we crossed in front of the moon. That's why the, the screen went completely white. But we ran into this object, and I saw it. Okay, this is cool. And it's called the Intergalactic Wanderer. Like, that is one of the most epic names for an object I've ever heard. So this tiny little dude, oh no, is one of the most distant globular star clusters in the Milky Way. So a globular star cluster is a giant, kind of like a family of stars with hundreds of thousands of stars. This guy specifically is about 300,000 light years away. So like the most distant glob we know of in our galaxy. The reason why it's like super extra faint, we've got this weird rainbow going on, is because it's like right next to the moon right now. But, you know, this glob is like on the complete opposite side of the galaxy from all the other globs in our galaxy. It is 2 times farther away than the Large Magellanic Cloud. It's wild that, you know, just barely we can see him a little bit today. Let's go around here. NGC, what is it, 2467. Was that visible? Or did we see that already? 2467. An open cluster, fun. I like open clusters. Open clusters and globular star clusters, to me, look like diamonds thrown up into the sky. Nice. So you'll see on the program, we passed in front of the moon again, oops. The program that we're using, we can easily type in the name of the object. We can type in the right ascension and declination of an object we want to look at. And the camera will look on over. So I believe this view here is the open star cluster. So what an open star cluster is a globular star cluster will have like hundreds of thousands of stars. Oh, fun. Okay, so we can see that these are younger stars. So we see this sort of nebulosity hanging out in the upper portion of the view. Wow. And that's like a part of the open cluster. I like that a lot. That's really pretty. So an open cluster is a younger group of stars. It'll only be like a couple thousand stars versus globs will have hundreds of thousands of stars. We also know that, open star clusters, they're younger stars, and they're called open clusters because they're slowly drifting apart from each other because of a weak gravitational pull. On the contrary, with globular clusters like the intergalactic wanderer we saw maybe just barely a second ago, those guys are very strongly gravitationally bound together. So scientists named them the very sciencey science term globbed together. We've got a lot of requests. Okay, let's see. The NGC 4565. Were we able to grab that? NGC 4565. I believe if it's possible to get a positive and a negative view. We passed in front of the moon again. Love that for us. Oh, hello. Maybe we passed in front of the building? Oopsies. Oh, sorry. Yeah, 4565 is too low. We are in the building. Okay. Let us see. Were we able to see M10? Was he too low? Or M110? Okay, my apologies. M110 is a galaxy. So we're jumping on over to him now. Let's see if we're able to get a... Okay, cool. So M110 is actually a part of the Andromeda Galaxy. I believe it's one of the satellite galaxies to Andromeda. Nice. Okay. So is that the core of Andromeda or the core of M110? I believe that's the core of the Andromeda Galaxy. Okay, so this is the core of M110. Awesome. Okay. This guy is within the Andromeda Galaxy. I believe we can up the exposure, maybe get a little more definition. But that sort of a brighter smudge in the center there is where, that supermassive black hole is. That's kind of keeping together the whole galaxy. We can see with more exposure, more of that sort of looks like haze, but that haze is actually individual stars. We just don't quite have like the resolution to see those individual stars. So about 2.5 million light years away, this little galaxy is hanging out. Okay. Okay. The asteroid. So looking at asteroids like Vesta, it would be difficult to it would be in the frame, but we wouldn't really be able to tell it was an asteroid. It would look like a single star. We'd be able to tell it was an asteroid if we took like an image now and then an image in 2 hours. We would see this little dot move. What is your favorite thing to look at? Right now, I believe this was a request as well. It would probably be M42, which is the Orion Nebula. Now, the Orion Nebula, it's one of my favorite objects in the sky. This is a M42. Sorry. Sorry. Yes, perfect. Yes. Wow. Yeah, the Orion Nebula is a star-forming region about 1,300 light years away. So what we're seeing here is this sort of a darker cloud in the front. That's a dark nebula. And inside of that gas, that is sort of helping all of these, thousands of sun-like stars to form. We can see this primarily ionized hydrogen gas, that red gas in the back. I think also if we could down the exposure a little bit, we would be able to see the trapezium. or maybe I go into video mode and we up the exposure time. So we can see these 4 little dots in the center there. Nice. And that's called the trapezium. So we're able to see like these little baby stars in the center of that nebula. Yeah, I love the Orion Nebula. I think, you know, this really bright gas is super duper pretty. All right. M51, we can't quite grab right now. Zach, the Christmas tree cluster, we should be able to grab. It's a little close to the moon, but it should be fine. So another open star cluster. Star clusters come in all these different shapes and sizes. The Christmas tree cluster is supposed to look like a Christmas tree. To me, it looks like a bunch of stars. But this right here is another open star cluster. So, you know, some of them look a little denser than others. Some of them look way more spread out than others. It could also be that this open cluster is a lot closer to us, so we're not even getting like the entire cluster in the field of view because we just have too good of a telescope. Yeah, I love open clusters. They can, you know, yeah, come in all different shapes and sizes. Super pretty. Let us see. NGC 2298 may be a little too low, but we could attempt. That is a globular star cluster. Oh, it's a little too low, but we can try it anyways. Okay. Let's see if we're able to grab him. So we're taking an exposure. Nice. Cool, cool, cool. Oh, so with this exposure, we can actually see globular star clusters are a lot older than open star clusters. And you can tell the age of a star by its color. And with this globular star cluster, you can see these stars look pretty red, which means that they are older, cooler stars. With an open star cluster, like the Christmas tree cluster we just saw, those stars are more white or blue because they're younger, hotter stars. So that's nice. I like that guy. Let us see. We've got a lot of requests. I'm trying to hit all of them. 2298, that was cool. Okay. Zach Davis asks, how old is Lowell? We were founded back in 1894. So we are, what does that make us? 127 now? 126. I think our birthday, 127th birthday's this year. Woohoo, we made it. Let's see. NGC. Ooh, request to see NGC 2392. This is a really cool object. So this is a planetary nebula, called the Eskimo Nebula or the Clown Face Nebula or the Lion Nebula. I think we try really hard to name things after what they look like, but like Christmas Tree Nebula, it's just kind of like just look like a bunch of stars, but that's okay. The Eskimo Nebula is a planetary nebula about 6,500 light years away. We passed in front of the moon again. That's why we have this bright view. I think we're going to fix the exposure and the gain real quick, and then we're going to try to zoom in. Nice. Oh, look at that little guy, little dude. So we can see the dying core of a sun-like star in the center there. So a planetary nebula is the death of a low mass or average mass star. So in a couple billion years, that is what our sun is going to look like. We have the dying core in the center there, and that the dying core of that star is expelling out all of the gases and the elements that that star has created throughout its lifetime. So like we saw Messier 1 a little while ago, the Crab Nebula a little while ago. That was the death of a more massive star, heavier than average star. So we got heavier elements. With the death of a star like this, like the Eskimo Nebula here, we get lighter elements like oxygen and helium and nitrogen and things like that. But he kind of looks like a little lion's mane, doesn't it? I like it. Okay, let's jump to, we saw M42 a second ago, NGC 2903. It might be a little dim and cloudy, but we could still try to get it. Also, these catalogs that I'm talking about, you know, I keep saying like M42, that is the Messier Catalog. This NGC catalog is the new general catalog. So just like, kind of like a newer catalog than Messier, the Messier Catalog, like more distant objects or dimmer objects. That is neat. Ooh, so we're getting a little galaxy action going on there. So we can see that really bright core in the center there. We can also just barely see, it looks like a barred spiral galaxy, meaning we have the core of the galaxy, that lighter portion in the center, and then we have what looks like this sort of like a toothpick or a bar going through it. And then like coming off to the right and like down to the like top right to the middle right, and then bottom to the middle left, we can see these spiral arms. And these spiral arms are where star formation is occurring, and that's why we're able to, you know, what a spiral galaxy is those spiral arms are usually giant star forming regions, so filled with regions like the Orion Nebula. Cool. I like that. Jose requests Iota Cancri? IOTACANCRI. So a bicolor binary. Cool. I love binary star systems because I think of them as kind of like the suns in Star Wars, where you know, if there was a little planet orbiting these two stars, that planet would have two suns in its sky. So I think we're going to try to jump on over there. Bask in front of the moon again. So let's see other guys. Nice. Little dudes. Aww. So it's a bicolor binary because one of the stars looks a little more red and the other star looks a little more blue. So these binary stars are kind of like, you know, gravitationally bound to each other. So they're going to orbit around each other. So that more massive star, you know, might not move as much as the smaller star orbits around it, or they could be, you know, completely equal masses and they could just orbit that very center, that center of mass. You know, there's a bunch of different outcomes with binary star systems, but it's cool as well because for the most part, binary stars, when you look at like all of the stars in our night sky, they all pretty much look like single stars, but over 60% of the stars in our sky are multiple star systems, like these binary stars, and we can't really see that they're binaries until we view through a telescope. Let's see. NGC 1023 should be a yes. That should be probable. Another object from the new general catalog. So another little galaxy. I liked that barred spiral galaxy we looked at earlier. That was cool. I forgot who requested it, but that was really neat. So we're up in our exposure again. Let us see what happens. So it looks more like an elliptical galaxy. Maybe as the exposure comes in more, we might be able to see some spiral arms. There might be spiral arms in there. But, you know, there are spiral galaxies, there are elliptical galaxies, there are spiral galaxies, elliptical galaxies, or irregular galaxies. Those spiral galaxies, like the one that we saw earlier, will have those star-forming regions in them. Elliptical galaxies kind of looks like this guy's elliptical, mean that there's less star-forming areas, so less of a, you know, those gases used to form those stars those gases that formed those stars have been used up, those stars have been formed, and it's less so a spiral structure and more so just like a giant glob of stars or a giant family of stars. Let us see. the NGC 457, the Owl Cluster. I love the Owl Cluster. That's one of my favorite open clusters because it actually looks like what it's named after. I believe this guy's like around 4,000 or 5,000 light years away from us. So we are taking a 10-second exposure right now, and it will look like we have like these little eyeballs and this little body made of stars and like little wings kind of going out made of stars. Yeah, nice. So those two bright stars kind of to the upper right are like the eyes of the owl, and then just beneath it, kind of going down into the left, that's like the body of the owl. The wings are sort of extending up, and the two brighter stars sort of in the middle of the view look like the little toesies of the owl. It might have just been because I've looked at this object so many times that I've tricked my brain into thinking that that's what it looks like. Let me know. Let's see. M1, which one is this one? M108? Messier 108. Cool. So another galaxy. It's fun to get different views of galaxies, and we're kind of jumping all over the sky as well. I believe this guy is in Ursa Major, the request from Jeff H. Were you able to grab him? So the reason why we see these streaks going through the view is because we're taking an exposure as the telescope is moving. So we're not like catching UFOs or anything, or we're not catching shooting stars. We're just taking a picture and moving the camera at the same time. Nice, yeah. So M108, it looks like we can see some little star-forming regions or some sort of shaded regions. So a younger galaxy with star forming happening. Let's see. Messier 97 is behind the building right now. I would look at it though. Let's try Messier 76, Little Dumbbell. Hi, Jose. The Little Dumbbell is another planetary nebula. So we saw the like Lion's Mane Nebula or the Eskimo Nebula, the Clown Face Nebula a second ago. You can see that, not only, open star clusters look completely different depending on the cluster that you look at. Planetary nebulae also look super different depending on which one you look at. With the moon bright, it might be a little faint tonight, but we should still be able to grab the Little Dumbbell Nebula. Yeah, it's a little dude right in there. So we can see these different colors are actually different elements that star has created throughout its lifetime and is sort of emitting throughout its lifetime. So I think we're going to do maybe one or two more objects before we dip today. So let's try the Beehive Cluster. Danielle asked, why is the Beehive Cluster called so? Because apparently it looks like a beehive, but they all kind of look like that to me, except for the Owl Cluster. That one definitely looks like an owl or an angry lobster, or that one scene in the E.T. movie when he's like running in the kitchen. That's what the Owl Cluster looks like to me. Anyways, we're looking at Beehive now. We passed in front of the moon one more time. It's our lucky night. The moon's mad we're not looking at it anymore. But so the Beehive is a lot closer of an open cluster. So when we're looking at it, it will, we're only looking at a portion of it. Ooh, are we looking like right next to the moon? Is that why we're getting this little moon bow going on? Moon bow, cool, they're fun. Cool, yeah, so we're fixing our settings right now, but we're getting this, more densely packed area of the sky, which is called the Beehive Cluster. Again, our telescope's just so big, so good that we're so zoomed in, we can't get the entire thing. Now, for the last object tonight, we're going to try to jump on over to NGC 891. So this will be our last object, and we're also able to catch this object in a negative view. Astronomers like to take images in positive and negative, because in the negative view, we can actually like see certain features that aren't super common, or that wouldn't be noticed in like a positive view. Jose, what binning are we using? We're using 2x2 binning tonight. Are we able to? Cool. Okay, so we're going to up the exposure a little more. Is this the Needle Galaxy? So this is neat because, we're looking at galaxies are kind of like plates. So, we can look edge on, we can look face on. They can be, space is a 3D thing and they can be thrown around wherever. Now, what we're seeing here is a galaxy, instead of looking at us face on, like if it was a little egg, we don't see the yolk and then the white. We're just seeing like the white part here, and then the yolk is just barely coming out in the center there. Like that bright portion in the center is the galaxy center. So we're looking at this galaxy edge on. So we can see this darker streak, like kind of like going down. That is those star forming regions. And then nice, cool. So flipping into the negative view, we can see that that darker streak is more like lighter now. So the star forming regions are lighter, and then that core of that galaxy, that really bright area, is a little darker now. So we can see exactly where that core is, and see it spread out like that. But yeah, if we want to flip back over to positive view, with that. Thank you guys so much for tuning in to tonight's edition of Interactive Stargazing. And we will see you next time. So thanks again.